Hello and welcome everyone. Thank you for joining us today for our webinar titled the State of the Art NLP Models in H2O Driverless AI. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speakers. Sudalai Rajkumar, also known as SRK, is a Kaggle Grandmaster and data scientist at H2O.ai. Maximilian Jeblick is a Kaggle Master and data scientist at H2O.ai. Trushant Kalyanpur is a data scientist at H2O.ai. Now, before I hand it over to Trushant, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Now, without further ado, I'd like to hand it over to Trushant.
Hey, thanks, Patrick. Hello, everyone. So we are all really excited to showcase the latest NLP capabilities in Driverless AI 1.9. So let's get started. So before we dive into the details of what's new in 1.9, let's talk about why we look at BERT models. So these models have been pre-trained on really large corpus like Wikipedia, and that's really a rich source of information. Right? And what's great about these models is that they capture the context of words, and it does so bidirectionally. Right? So if you look at the transformer architecture that this is based on, they rely on this attention mechanism. And what that does is capture not just the representation of the words themselves, but in what context those words are used in the sentence. Right? And traditional architectures, they typically take in the sentences and feed in the text either from left to right in one direction. But these models take in all the words in a sentence or text block at once. Right? So it's kind of directionally invariant. And that helps capture the context really well. These models also take advantage of parallelism to speed up execution. So similar to the point before, if you look at traditional architectures like LSTM, they are sequential in nature, right? They rely on the completion of one block, and then the blocks downstream need that block to process further, right? But in the transform architecture, a lot of things can be done in parallel, and that's really useful in sort of optimizing how these things can be processed parallelly. And we'll see this in the demo as well, especially when using GPUs. This can speed up the training time significantly. And since we have these rich pre-trained models, all we need to do is fine-tune just typically like a single additional layer, and then you can use these models for a wide number of NLP tasks. And these models have proven to deliver state-of-the-art results on a wide variety of NLP tasks, right? So be it question answering or sentiment detection or classification tasks, they provide some of the best results. And so it's no surprise that Google uses BERT even for their search queries, right, in Google search. So with that being said, sort of in Driverless AI 1.9, we now have the ability to use these BERT-like models, right, that have these transformer architectures. So we do support feature engineering. So both BERT and DistilBERT models can be used for embeddings for data sets that have any number of text columns. And this can be also useful if you have sort of mixed column types. Let's say you have text columns and as well as some columns that are categorical and numerical. You can still use these BERT-based models for generating embeddings. And these embeddings can then be used downstream in any model. Right? And that can be really useful. Apart from feature engineering, we also can use these models as modeling algorithms. And models like BERT support multiple languages as well, and that can be really useful in some use cases. We also support scoring for these inbuilt models. So C++-based Mojo scoring, which do support both Python and R-based wrappers. So we support both BERT and DistilBERT for the C++ Mojo, as well as Python scoring for all the available models that we ship out of the box, right? So what you see is we now enable driverless AI users as well as data scientists to run these state-of-the-art NLP models within the driverless AI framework and essentially use these world-class models in production, right? And that's something that's really powerful. So let's take a look at the first thing, right, the feature engineering. So if you look at what we had prior to 1.9 release, we could take text columns and use either TF-IDF or word or character level embeddings and generate features based on either RNN-based models or CNN models, right? And starting 1.9, we can now use this BERT and DistilBERT-based models to generate embeddings, and then these embeddings can then be used downstream for any model. So let's take a quick look, snapshot of what that looks like. I will be going over a demo of how to do this, but this is just to show you what the outcome looks like, right? So you see, once I enable BERT and DistilBERT-based feature engineering, they do land up being sort of the most important features, right? And they outperform our sort of baseline BiGRU CNN features that we talked about. So let's jump to a quick demo of how to set this up. I think that'll be really useful. So what I've done here is I've created a project workspace and I have pre-run some experiments. So the baseline experiment is similar to what we have prior to 1.9 release, right? So I've enabled some of the NLP transformers. So we have our TensorFlow-based models, we have BiGRU and CNN. And you see, without the BERT models, they come out as top features. There's no surprise there. And what I'm going to do now is use this baseline model to enable BERT-based feature engineering. So let me show you how to do that. I'm going to start the same baseline experiment, but navigate to the expert settings here. And you see right now it doesn't show any BERT models in the experiment preview, right? And this is the best place to see what's going to happen. So in the expert settings, what I'm going to do now is go to the NLP tab that we have. And by default, this PyTorch models, which are all the BERT-based models, is going to be in auto mode. What you want to do is set this to on, right? If you want to use BERT-based models either for feature engineering or for modeling purposes, right? And in this case, since I just want to show you the feature engineering, what I'm going to do is just disable them as models, and then quickly do a save, and then let's look at what the feature preview looks like, right? And this is the best place to check. And what you see now is essentially the BERT models start showing up for feature engineering, along with all the other feature engineering steps that we have. Okay? And I can go ahead and launch the experiment, but what that's going to look like is the second experiment here, right? And what you can see is once you enable the BERT models, it typically takes, and in this case, you see it's almost the same time, if not shorter than our baseline experiment, but it has a significant improvement in the test scores, right? You see the log loss here, which is the lower is better here. So we've improved significantly on the test score, right, going from 0.5 to 0.42. And if you look at what the model did, you now see, similar to the screenshot that I showed you before, the best features that it finds are BERT and DistilBERT-based embeddings, right, that the GBM model in this case uses to generate the best model. The BiGRU and CNN still show up, but they are not sort of the most important features. But what you can see is once you enable the BERT models, you get a significant improvement in the score, right, without impacting your runtimes too much. And that's really powerful. And what I've also done is disable the CNN and BiGRU, and you see that that takes a significantly less amount of time compared to our baseline, right? In just 16 minutes, you can get a model that still improves a lot on our baseline, right? You see 0.45 versus 0.5, and now you'll only see sort of BERT and DistilBERT related features, and you don't see the CNN and BiGRU, right? But you see within a matter of 20 minutes, you can still get a significant improvement to our baseline, right? And that's really great. Okay, so we talked about the feature engineering aspect. Let's move on to the modeling. Right, so right at the box with Driverless AI 1.9, you get 8 different transformer-like architectures that you can use as models. So we have BERT itself, and I mentioned before, but we can use this for multiple languages. There's also DistilBERT, which is kind of a distilled version of BERT that has a lot less parameters. It has 40% less parameters than BERT, and it's a lot faster, but it doesn't sacrifice on the performance, right? So you still get 95 performance of the BERT-based models, which is really great. And there are some other architectures that we support as well. There's XLNET, and then some of the other models that came out of Facebook research. And then there's ALBERT, right, which is from Google, which is a light version of BERT. And then there's CANMBERT, right, which is very specific to the French language, but that's an option as well. And if you see, and I'll go over a demo of this, once you enable these models, you see BERT-based models showing up as the best models that it found, and the final model was actually an ensemble of 2 BERT-based models. Okay. So let me show you a demo of this again. So if you go to the project workspace, what I've done is I have a baseline by group and CNN model, very similar to what I showed before, right, the same score. And what we're going to do in that is just go ahead back to the expert setting, and now we're going to make sure we enable them as models, right? So if you look at the preview right now, you don't see any BERT-based models. If you go to the expert settings and the NLP tab, I'm going to enable the BERT models, and also select which models I want here for the modeling purposes, right? By default, we'll have BERT and DistilBERT-based models, but I can go ahead and try different combinations of the models that I talked about. There are some other parameters you can play around with here as well, the number of epochs, the max sequence length, if you're familiar with this, and also the batch size, right? And this can help in case you have different hardware. And once I do that, in the preview, you can now see that both for the model building and evolution, you see BERT and DistilBERT-based models showing up. Right? And if I launch the experiment, it's going to pretty much look like this completed experiment. Right? So you see, it does take a little bit longer, but keep in mind that I've enabled CNN by group transformation as well. But you see that it significantly improved the test score. Right? Again. And since I know this is a text-dominated problem, in this case I had multiple columns, right, a mixed column type, but the most important feature ends up being just the text column. Right? So what I can go ahead and do is build an NLP pipeline, and I'll show you how to do that. And what that's essentially going to do is similar to what we talked about earlier. I just use the pre-trained models and just do the fine-tuning, right? And the way to do that is to go to the experiment settings, and there's an NLP model feature. If I enable the NLP model, what's going to happen now is you're just going to see a final pipeline being built, and we just do the fine-tuning for the specific classification task, right? And it's just going to use BERT and DistilBERT-based models. It doesn't do any feature engineering, but it just needs the text, right? And this can be really useful in some use cases. And what you can see happens in this case is, in just 8 minutes, I'm able to get a really good model that's based on BERT and DistilBERT that outperforms some of these earlier models. Right? You get 0.42 scores. Okay. And you also see how useful it is to have a GPU. I've run the exact same experiment with the same settings on a CPU, and you can see that it takes significantly longer on a CPU. Right? So that's definitely something we recommend you should be using. It's definitely recommended to use GPUs to speed up training times for these transformer-based architectures. Okay. And let me show you one more thing. I think, so once you enable these BERT models, you see what Driverless AI tries, right? So you see some early iterations where it's building some light GBM models, where CNN by GRU land up being the most important features. But as Driverless AI tries some things, you see that it tries the BERT and DistilBERT models, right? And at that point, it reduces the log loss score significantly, right? Going from 0.5 to 0.4, and then it lands up just being an ensemble of BERT-based models, right? So it's trying different things here. And in this case, you can also say, okay, I really don't need to do these CNN by GRU, I can disable them. Right? All right, so that's the modeling portion. We do also support the scoring, and this is intended to just show you a quick demo of what the Python scoring looks like. This is based on the C++ module with the Python wrapper. So you see that I've imported the pipeline module file here, and then use that to just predict sort of 3 sentences that I have. And this is the sentiment detection, where we have 3 labels, right? Negative, neutral, or positive. And you see that scoring on these 3 sentences give you these scores, right? So the first one for I hate you is negative. It was okay lands up being a neutral sentiment, and I love you is like a positive sentiment, right? So you can see how we can use sort of the end-to-end pipeline to generate these models that can then be used in production. And that's really powerful. Now for the next piece, this is going to be talking about BERT recipes. I'll hand this over to Max, who can talk more about this.
Okay, thank you, Trushant. So as we have already seen, out of the box with driverless AI, you're able to use pretrained language models such as BERT, DistilBERT, Roberta, and so on. But if you have a domain-specific data set, it might be useful to use a pre-trained model which was also trained on a domain-specific data set. For example, you might have financial tweets, and you want to predict whether the sentiment of that tweet, which tweets about financial events, is positive, neutral, or negative. In this case, you might be able to use FinBERT, which is a BERT-based model which was trained on financial data, or you might have a scientific data set with very specific scientific language and usage. And in that case, you might use SkyBERT, which was trained on scientific papers found on archives and other data sources. Or you might have medical reports and want to classify them. And in that case, you can use BERT, which was trained on PubMed articles and really does well in the biomedical domain. So how does this work in driverless AI? You can upload the domain-specific language models using a bring your own recipe architecture. So we provide you with a template, and in that template you just need to specify either the model folder where your model is located on your computer, or you provide a download link where the model can be downloaded. You then upload the custom recipe and can use the domain-specific language model out of the box. The interesting thing about this is that the models I just mentioned, FinBERT, SkyBERT, and BERT, they all have the same architecture as BERT, so they use the same model architecture, but the weights are different. And because of that, you can use these models, train on your specific data set, and download the motor for that, and put it into production very easily. Let me now go over to the model performance. So that's the last slide I want to share today. And for that, I want to look at the Quora Instantiate Questions Classification Challenge. This was a challenge which was hosted at Kaggle about 1 year ago. And at that competition, the participants were asked to predict whether a question which was posted on Quora is insincere or not. So an insincere question might be either a toxic question, or it might be a question that doesn't make sense really. So in that competition, there were over 4,000 teams. They tried very hard and had very good ideas. And they tried it for over 2 months to improve on the leaderboard. And in that competition, you were allowed to use word-to-vec embeddings, and on top of that, you can build an LSTM or convolutional neural networks, but you weren't allowed to use broad models. As you see here, the final leaderboard standing, the top teams get an F1 score of 0.71. And if we now use the very same data set, upload it into driverless AI with the new BERT model, you will see that the BERT model will outperform, and we will get an F1 score of 0.72. So the higher the score is, the better. And the BERT model outperforms by quite some margin, I would say. And again, to wrap it up, you upload your data, train a model in very short time, get state-of-the-art results, and you're then able to download the module and put it into production at ease. Okay, so that's from the presentation side. Thank you. And I think we are now ready to go over to the questions part.
Great. Thank you, everybody, for submitting your questions. We have some great ones here in the chat window. We're going to try to get to most of them with time permitting. So first question is about validation versus test score, where it's asking, isn't the validation score the one to be considered as opposed to the test score?
So what we provide is, so the validation score is again on sort of unseen data. I'll split it in this case on a validation score, right? And the test is really unseen as well, right? And that is something that the model hasn't seen, and you see how the model performs on the test set, right? So we're looking at both scores here, and we see a significant improvement in both compared to our baseline. Okay.
Great. Okay. And then what's the difference between choosing the BERT models via the expert settings and not using the BERT models, such as transfer learning? So that's part one. And then part two is, what do both of these options do individually?
So if you look at the, go ahead. Yeah.
Okay. Yeah. Thanks, Trushant. So actually, as Trushant mentioned, so we have two versions. One is like in the feature engineering part, and the other one is in the model building part. So the difference between both of them actually is like, if we select them for the feature engineering, then we won't do any fine tuning over there. So we'll use the pre-trained BERT models. We just get the embedding from the last layer and use that for the feature engineering. But say like when we choose that in the model building part, we actually use the pre-trained model and do a fine tuning on top of that using the given input data set. So that's how like both of them differs. And as a result, like if we do fine tuning, it will take a bit more time compared to just using the pre-trained embeddings as such. Please feel free to add, Trushant.
Yeah.
Okay, thank you. And what is the difference between DistilBERT and ALBERT?
So they both came out of sort of different research groups. So DistilBERT came from Hugging Face, and it uses a very specific distillation approach to reduce the number of parameters, and it's a lot faster than the baseline BERT, right? And ALBERT came really out of Google research and Think Toyota Corp. And it's also a light version of BERT. There are some differences in the way that this distillation was done versus DistilBERT, right? But essentially, they're trying to both reduce sort of the number of parameters for the baseline BERT model, right? Because these are computationally intensive models, right? There's a lot of parameters in there. And you see a lot of these transformer architectures coming out on a regular basis.
Excellent. Can I use, can I use Word2Vec to create my word embedding and import it in the BERT model in your platform? And can I tweak the hidden layers of the default BERT model on your platform?
So yeah, so as of today, we use the the embeddings that come out of the BERT models themselves, right? And that's really what you want to use, because those capture the context really in both directions that we talked about, right? And with Word2Vec, you might lose that, but yeah, in the models today, at least, we rely on the BERT-based embedding themselves, right? And there's no way to change any of the hidden layers today, but that's something we can definitely look at if it makes sense. Right?
Great.
The parameters that you can pair are the batch sizes, the max sequence length, which is really of importance, right, and the number of epochs that you want to train, right?
Right. All right. What do BERT constructed features look like?
So the BERT, depending on the type of model you use, these can be really wide sort of embeddings. So we do some things to kind of reduce that, but the embeddings typically just look like a really wide matrices, right? That are just numerical. Right?
Great, thank you. And then this is kind of a combined question here where, so are there any pre-trained models for a specific domain or industry such as manufacturing? And even furthermore, does that differ, how do you handle that differing from country to country, like EMEA versus North America, for example?
Mm-hmm. Yeah, that's a good question. So I think Max touched upon this point of custom recipes. And if you look at what's sort of out there, and if you come across a model which is open source and fix a specific domain solution, all we have to do is use this template that we have. This was for a financial data set, but there's no reason you can't use this for something else. And you just need to provide it the model path for the model, the open source model, as well as the config and vocabulary files, and you can just inherit some of the BERT models that we deliver out of the box. Right? So depending on the domain solution, you just need to change a few parameters here, and you can start using those models in Driverless AI.
Great. I think we have time for maybe a couple more questions here. Can you elaborate more on the explainability for the NLP models and what the metrics mean?
Sure. So yeah, NLP in these models is going to be interesting. I think we have to do some additional work to look at how to improve the explainability for these BERT models, right? What are these models really looking at when we're looking at either attention, and see how we can present that in a format where you can at least get some more insight into what the model is really looking at when it does sentiment detection or classification, right? But that's something that we have to work on, and you'll see that coming in the product in the future.
Great. Last question here. Is H2O Driverless AI available to run on Google Cloud for trial? What do I need to do to get to try it on Google Cloud?
So we do support GCP install as well, I believe. So you should be able to run it in a GCP environment and just get a trial license and try it out there.
Right. Actually, yeah, and I can actually add to that. We do have a free trial license on our website. The link will be attached to this webinar, and you will all receive that link about tomorrow around the same time of the webinar start time. And the H2O Driverless AI is available on every cloud marketplace. You can get to it from our website, h2o.ai/downloads, or searching for Driverless AI on the marketplace of your choice. And I think that does it for all the questions that we have today. I want to thank SRK, Max, and Trushant for taking the time and doing a great presentation today. I'd like to say thank you to everyone who joined us as well. The presentation slides and the recording will be made available on our BrightTalk channel. And we hope you have a great rest of your day.
Thanks, everyone.
Thank you.
Thank you very much.